Hello everyone, this is the second of 3 lessons that I'm putting together for you. That is on naming and writing the formulas and properties of different kinds of compounds. So the previous one, kind of a long one on ionic compounds. This one here is on molecular compounds, and the last one will be on acids and bases. Hopefully this one won't be quite as long as that previous one that I did on ionic compounds. I'm just going to go out of here for starters, and I'm just going to pull up the periodic table that you have just to remind you of a couple of things. So for ionic compounds that we talked about, what we have is a metal from the left-hand side of the staircase. It forms the positively charged cation, transfers electrons to a nonmetal on the right-hand side of the staircase, forming the anion with a negative charge, and then they're attracted to each other because opposites attract, and that forms an ionic bond. So if we have one of these elements and one of these over here, that's called a binary ionic compound, and an example would be magnesium chloride. We can also involve the transition metals that have 2 different possible charges. Same sort of thing though. We could have manganese fluoride, metal and a nonmetal. We can also include these polyatomic ions, of which all of them act as the anion, negative charge nonmetal, except for the ammonium. So we could have ammonium nitride. We could have chromium 3 nitrate. So all kinds of different possibilities and ratios that we needed to determine using the crisscross method to determine the formula for ionic compounds. Molecular compounds. Here we're talking about only the nonmetals over here. So we're not concerned about the table of polyatomic ions. We're not concerned about any of these metals as well. On some periodic tables, they actually have hydrogen here on the left-hand side, and they have it right up here as well, tucked in at the top of group number 17. It is still hydrogen. It is still atomic number 1, and they put it over here as well because hydrogen can do some sort of strange things. It can lose electrons and act as the cation, but you'll notice here it can also gain an electron and act as an anion, and that's why they sometimes show it over here as well. Hydrogen can also form molecular compounds. So let's take a look at the molecular compounds though. So like I did with ionic compounds, I'll talk a little bit about the properties, what they're bonded between, what goes on with the electrons. So only nonmetals that we're talking about, we either refer to them as molecular bonds or covalent bonds. Polyatomic elements. So this is different than what we talked about with the polyatomic ions. These are polyatomic elements. They are actually compounds. They are molecular compounds, but they're only made up of one type of element. One type of element, but more than one attached together. So that's a list of all of these in the brackets here. So oxygen that you breathe in, that your cells do use for sight or respiration, is this here, oxygen. It is 2 oxygen atoms that are bonded together, and it's actually bonded together. I'll draw a property here using a double bond that you don't really need to know anything about at this point. Hydrogen, 2 of them together, nitrogen, 2 of them together, bunch of these, 2 of them all together. Phosphorus, whenever you're told phosphorus, you never write just 4. It's always P4. Sulfur, whenever you're told sulfur, it's never just S, it's always S8. So be careful whenever you're told any of these. Nitrogen in the atmosphere is N2. It's always 2 of them together. So don't make that mistake eventually when we get to different kinds of reactions. You'll notice that oxygen, this other one here as well, O3, that's another possibility for oxygen, and that is ozone. To help you out a little bit with this, I'm going to go back to the periodic table and show you on the periodic table where we find all of these elements. So if you take a look at nitrogen, atomic number 7, oxygen 8, fluorine 9. And then if we go down, all down group 17, and include hydrogen that I said sometimes fits here, all of those are diatomic. It's two of them that are always together. So it's N2, O2, F2, Cl2, Br2, I2, At2, and H2. Kind of think of it like this. It looks like a 7 on your periodic table. Nitrogen, oxygen, fluorine, and then down, and then the hydrogen up above, which is also the H2. Tucked in here, phosphorus. Phosphorus is really P4. Sulfur on its own, I should say, sulfur on its own is S8. Notice it gives you the states here as well. P4 is solid. S8 is solid. All the other ones are all gas, except for bromine that we find here, which is a liquid. So hopefully that helps you, because you do need to kind of remember this. You do need to memorize that. What goes on with molecular compounds is that instead of transferring electrons, as was the case with ionic compounds, we have the sharing of electrons. It doesn't change anything in terms of stability. The point, once again, is to fill the outer energy levels to ensure that we have stability. So let's talk about this one here. Water, H2O, which of course can exist in solid, liquid, or gas. Most of the time, of course, we talk about it at room temperature, where it is a liquid, so we'll write that in brackets. So what does the formula tell us? For every oxygen, we have two hydrogen. So let me do this. Let me draw the oxygen first. O in the middle. That's going to be our nucleus. And what we do know, going to the periodic table, is that it is atomic number 8. So we have 8 protons in our nucleus. Energy levels, and I'm just going to do this for water. I'm not going to do it for any of the others. We have 2 energy levels here. How many electrons do we have in each one of these energy levels? Well, the first one, of course, we have 2 electrons. How many do we have in the outer energy level? Well, it's in group number 16. Second digit tells you that there's 6. Or 8 protons. If it's the atom, it needs to have an equal number of electrons, so that would be 6 electrons plus the 2 would give us 8, so 6 electrons in the outer energy level. What does that mean? It's not full. We want it to be full, so it looks like the nearest noble gas, which would be neon, because right now it's not stable. So what are we going to do? Well, we're going to throw in a hydrogen. So for our hydrogen here, let's draw one over to the left-hand side. So hydrogen in our nucleus, we of course have one single proton. It's only in the first period, so it has one single electron. It is H2, which means we need 2 hydrogens, so I'm just going to draw the other one. Over at the right-hand side here, draw exactly the same for our Bohr diagram. Might have been a little bit easier for me to draw the Lewis diagram. And there we have our other hydrogen. So for molecular compounds, we do not have the transfer of electrons. We have the sharing of electrons. What does that mean? Well, out of all these electrons here, and actually I should maybe rewrite this, and I'm going to draw each one of these electrons in the oxygen a little bit different here. So let me just get my eraser here first of all. I'm just going to erase that 6 that I put there. And just to make this a little bit clear, I'm going to draw all 6 of them. Okay, so I'm going to draw 1, 2, 3, 4, 5, 6 electrons. So when we talk about the sharing, what we mean is that, well, the electrons on the hydrogen, they're not just associated with the hydrogen, they're actually associated with the oxygen as well. So these ones are shared. So what does that mean? Well, in the outer energy for the hydrogen, I don't just get to count this one, I get to count both of them, which means it has 2 electrons. Its outer energy level is full. Here, the other hydrogen, they get to share these electrons. So same thing, we have 1, 2 electrons. They share 2 electrons in the outer energy level. It's full. That hydrogen is happy as well. Now let's take a look at the oxygen. We already had 6, but now we get to count this one here as well from the hydrogen on the right, and this one here from the hydrogen on the left. So adding all of those up, we end up with a total of 8 electrons in the outer energy level. It is now full as well. So all of this is due to the sharing, not the transfer, but the sharing of electrons. But this does still form a bond in both locations here, and this bond is referred to as a covalent or a molecular bond. No ions, no transfer of electrons, no charges, no metals. So that's really the first thing you look for. If there's no metal, it's not an ionic compound. We talked a little bit about the properties of ionic compounds. How about the molecular compounds? Ionic compounds are all solid at room temperature. For molecular compounds, a little trick here, they can be solid, liquid, or gas. So this makes it, a little bit more difficult. So for example, table sugar is sucrose, and it's solid at room temperature. Lots of gases. So oxygen we mentioned is a gas. It's at room temperature. And liquids, few of them, alcohols, for example, various different alcohols like ethanol in alcoholic beverages. That one is a liquid at room temperature. So for some of them you should know. So yes, you should know that oxygen is a gas, carbon dioxide is a gas, methane is a gas. You should know that, well, water is a liquid at room temperature. And yeah, you should know that things like sucrose, table sugar, they're a solid. But most of the other ones you won't know, so you will need to be told whether they are solid, liquid, or gas. And then we would use the subscripts. Again, S for solid, L for liquid, G for gas, and another one not here but we'll come across with acids is a Q for acids. Ionic compounds conduct electricity. Molecular compounds do not, at least do not usually. A couple of exceptions when they are mixed with water and they do conduct electricity because of ions that they form. But that's a little bit more complicated how that happens. So for the most part, if we do take oxygen and it dissolves in water, it doesn't conduct electricity. If you mix table sugar in water, it mixes, but it doesn't conduct electricity. These ones typically have lower boiling points than ionic compounds as well. Okay, so let's jump into the naming and the writing of the formulas. So molecular compound names, they use now prefixes. So you do have these prefixes on the back of your data sheet, the back of your periodic table. It has these prefixes mono, di, tri, tetra, penta, and so on that you need to use to specify the number that you have for each of the different atoms. So we didn't have to do this, for example, with ionic compounds. So if we do have Na2O, this is sodium oxide. You don't have to specify that there are two because this is the only possible combination. This is the only ratio, a 2-to-1 ratio of sodium to oxygen or oxide. However, with molecular compounds, it can be different. So we can have, for example, SO2 and we can have SO3. So now you need to specify which one by using prefixes for the 2 and for the 3, the di and the tri. So how do we name them? Well, whatever element appears first, you name first in full. So in these ones here, sulfur appears first. Sulfur is what you name first. Here, it's only a 1. That would be mono, but we usually drop, except for a few exceptions. we usually drop that mono. Second element, just like with ionic compound nonmetals, we change the ending to IDE. And again, if there's mono, we usually drop that as well. Okay, these are the prefixes that I did mention. You don't need to memorize this. It is on the back of your data sheet. So let's just take a look at a couple of examples. There is no metal. That's how you know that it's a molecular compound. So always ask yourself the question, is there a metal? Yes, it's ionic. No, it's molecular. And use the rules for naming a molecular compound. So what does that mean? Find S on your periodic table, name it in full. All lowercase letters, it is sulfur. There is one of them, there is a 1 here, but we don't write it, and we don't write the name mono. The prefixes always go in front. So if we were to write a prefix, this is where it would go, in front, monosulfur, but we just drop that. Now we have the fluorine. We're going to change the ending to fluoride, and we need to say how many there are. The prefix for 6 is hexa. So this becomes sulfur hexa fluoride. Prefix, IDE ending, whatever element is first, they're both going to be nonmetals, right? Whatever one is first, you name first. Whichever one appears second in the formula, you simply name second. This one here, Ni, this is not nickel. Nickel is capital N, lowercase I. That is a metal. It is a solid. This one here, 2 capital letters, 2 different elements. N, of course, is nitrogen. We write that in full. Why are we writing nitrogen first? Because it's first in the formula. There is one of them, but we don't need the mono in front. So now we go on to the I. I is iodine. We're going to change the ending to IDE, and we need to specify that there are 3. Again, the prefix goes in front, so this is tri, nitrogen triiodide. Triiodide. This one here, SO2, sulfur. We name first. Oxide, there are 2, that is dioxide. I'm just going to write that other one that I showed you as well, SO3. This would be sulfur trioxide. And I do want to bring this one up because you have to be really careful when you do take a look at your table of polyatomic ions. What you will see is that there is a sulfate and there is a sulfite. Sulfite is SO3 2 minus. SO3 2 minus. So be careful. Let me just grab my pen back. SO3 2 minus. This is not sulfur trioxide. This is sulfur trioxide. Notice that for all of these, again, they are compounds, they are molecules. There is no charge. As soon as you see a charge, this is a polyatomic ion. This is not sulfur trioxide. This is sulfite. So don't mix those ones up. That is kind of a common mistake. How about the opposite? So now, instead of starting with the formula, as we had here, and writing the name, we're going to start with the name, and we're going to write the formula. Write down the chemical symbol, of course, for each element in the order that they appear in their name. You need to write the subscripts whenever you are given a prefix that is greater than 1. In other words, not mono. So let's take a look at just a couple of these. Let's go carbon, tetrachloride. First element that we have, or first of all, is there a metal? There's no metal. Because there's no metal, this is a molecular compound. Use the rules for writing the formula for a molecular compound. First one that appears, that's the symbol that we write first. Symbol for carbon is C. Element that is second, that's the one we write down second, and it is Cl. Carbon, there is one. So this is a mono, but we don't write the mono. But there is a 1, and we don't write the 1 after the carbon. However, this here does refer to the chloride, and it means that there are 4 of those that we do have. Let's just do one more. Let's do nitrogen dioxide. Nitrogen dioxide is a gas. Nitrogen, write that symbol first. Oxide for oxygen. There is 1 nitrogen. We don't need to write it. Di means 2. There are 2 oxygen. This one here is a gas. That's about it for naming and writing the formulas for molecular compounds. So there were those molecular compounds, the ones that were the diatomic ones. If I just quickly go back to those again, so we can take a look at those. Some that you do need to memorize. The molecular compounds, all of these ones here. So it's not exactly memorized as long as you know where they are on the periodic table, sort of in that shape of a 7. Shape of a 7 that we see. At least that's for the oxygen, the nitrogen, the fluorine, the iodine, the bromine, the antimony, the chlorine. They're in the shape of a 7. All of those are 2. Cl2, At2, Br2, and so on. Phosphorus, P8. Sulfur, S8. You simply need to, remember that. Keep that in mind. These ones here have some kind of different rules. These are memorization ones. So O3 is not just oxygen. O2 is oxygen. O3 is ozone. Of course, we don't call this one here dihydrogen oxide. We call it water. H2O is water. This one, NH3, ammonia gas, is not nitrogen trihydride. It is ammonia. Methane is natural gas. So this is gas that you use to heat your home. If you have a gas stove, it uses methane. If you have a gas barbecue, it uses methane. Methanol, where you see an OH and no metal, that is an alcohol. So this one here, OL, is an alcohol. Propane is another fuel. Again, if you have a propane tank that you use for your barbecue, this is propane. Hydrogen sulfide. This one here is typically not called a dihydrogen sulfide. It is simply hydrogen sulfide. This one here, hydrogen peroxide. Sucrose, you should recognize along with the other sugar, glucose at the bottom here. Another alcohol, ethanol. This is the alcohol in alcoholic beverages. Octane, major fuel that you find in gasoline. Butane, major fuel. Well, that's the fuel in butane lighters. So this is a fuel. This is a fuel. This one here is a fuel. Natural gas, of course. That one's a fuel. So these ones, you do need to, unfortunately, memorize those. And that's about it then for the molecular compounds.